All right, today we're going to start what's called the ideal gas law. So, before we work with the combined gas law, which compared two different situations using the variables pressure, volume, and temperature. So let's just remind ourselves of the four gas variables. And so the three that we've been working with are pressure, volume, and temperature. The fourth is one we haven't worked with yet, but it's a number of moles or number of molecules. So remember, I'm going to put number of moles because moles is just a measurement of molecules, right? So 1 mole equals Avogadro's number, 6.02 times 10 to the 23rd. So if I say number of moles, number of molecules, it's really the same thing. It's just how we count the molecules. So the relationship is called the ideal gas law, and that's pressure times volume equals N, which is the number of moles times a constant R, and then T is the temperature. So here's everything I just said. And so before, in the combined gas law, remember, you could almost use any unit as long as those units matched up. For example, if P1 was in kilopascals, then as long as P2 was in kilopascals, that was fine. However, here, these have to be a specific unit. And actually, it tells you the units here. So volume always has to be in liters. The number of moles of gas, that always has to be moles. And the temperature has to be in Kelvin. The pressure can either be in atmospheres or kilopascals. So those are your two choices. And then the R is a constant, meaning it's a number we give you. It's either 0.0821 or 8.34, depending. And what does it depend on? Well, we use, if you take a look at the units, we'll use this if the pressure is in atmospheres. And then we'll use this one if the pressure is in kilopascals. Okay? Right. Okay, let's take a look at our example. So how many moles of gas are contained in 3.0 liters tank at 300 Kelvin and 1.5 atmospheres? So it says how many moles. We're solving for N. Our pressure. So let's do what we normally do. We know. So it says how many moles. So we want to figure out moles. 1.5 atmospheres. Our 3.0 liters, and the temperature is 300 Kelvin. So the R value we're going to use is 0.0821. And it's going to be liters, atmospheres, over Kelvin times mole. All right, so let's plug it in. So 1.5 times 3 equals N, which is what we want to solve. R is 0.0821 times the temperature here. So we need to solve that. Let me get my calculator out. So 1.5 times 3 is 4.5, right? And then 0.0821 times 300 is 24.63 times N. So 4.5 divided by 24.63. So N equals 0.183 moles. Okay. Next one. So what is the temperature required for 0.0470 moles of a gas to fill a balloon to 1.20 liters at 100.3 kilopascals? So now oftentimes on the test we'll ask you these questions, but you have to determine, am I going to use that combined gas law, P1 V1 over T1 equals P2 V2 over T2, or am I just going to use PV equals nRT? And one key factor is if I see moles, right? So if I'm deciding between this one, the combined gas law, versus the ideal gas law, one of the biggest difference is you have an N, which stands for moles. So I know, okay, I'm going to use PV equals nRT. Okay, so now that I know I'm going to use PV equals nRT, the pressure is what, no, we have the pressure 100.3 kilopascals. The volume is 1.20 liters. We know that we have 0.0470 moles. The temperature is what we want to figure out. Since I'm using kilopascals, I'm going to use that R value that is equal to, I think it's like 8.31 something. 8.31 is fine. That's what I normally use. And it's going to be liters times kilopascal over moles times Kelvin. Let's plug it in. So 100.3 times 1.2 equals, and then 0.0470 times our temperature times R. I kind of rearranged it a little, but that's okay. So 100.3 times 1.2 gives us 120.36. 0.0470 times 8.31 is this 0.39. I'm going to round it to 1. Temperature, so 120.36 divided by. So this temperature is going to equal 300 and, how many sig figs do I need? I got 3, 4, and 3, so I need 3 sig figs, so 308 Kelvin. Okay, you can convert to Celsius if you wanted to by subtracting 273, but you don't have to. But if you wanted to convert to Celsius, you'd get 35 degrees Celsius. It's up to you. I didn't say you had to, so you don't have to. You can keep it in Kelvin. All right, the next one. If the pressure of a nitrogen gas at 25 degrees Celsius in a volume of 0.044 liters is 3.81 atmospheres, how many moles of gas are present? So I see moles, so I know I'm going to use PV equals nRT. So let's do our identification. So this is going to be 25, but we're going to add 298, right? Or sorry, not 273. It equals 298. Our N is what we want to figure out. This is 0.044 liters, and then the pressure is 3.81 atmospheres. All right, let's plug it in. 3.81 times 0.044 equals, N is what we figure out. R is going to be, since we're using atmospheres, 0.0821 times, and then our temperature 298. Okay, I'm going to solve for this, and then I found out times 0.044. I'm just going to go ahead and solve it all the way through. And I got 0.006, and I'll go to 3 sig figs, and I'll tell you why. I should be at 2 sig figs, but I know that eventually I'm going to figure out grams, so I'm going to keep an extra sig fig there. So 0.00685 moles of N2. I got to convert to to grams. So remember, 1 mole of N2 is 14 times 2, 28.02 grams. So I'm going to multiply this by 28.02. So 0.19 grams of N2. Okay. So we start basically converting moles to grams, grams to moles with these type of problems. Okay, take a look at the next one. So one thing you should notice is, remember, we have to choose between, right? And so in this case, what I want you to notice is there is no moles. As you read, there's no moles. So we're probably looking at one of these. The second way I know that it's ideal gas law, combined gas law, is you have an initial situation, right? And then the situation changes where now you have standard pressure in 25 degrees Celsius. So whenever you have two different situations, or you have an initial situation, that situation changes by changing pressure or temperature. What you're doing is you're using the ideal gas law, or sorry, the combined gas law. So I'm going to go ahead and put everything out like I normally do. So this pressure is 2.5 atmospheres. This is 2.0 liters. This temperature is -20. So -20 plus 273 gives you 253, right? This P2 standard pressure is 1.0 atmospheres. Our V2 is what? Oh, sorry, this should be volume, not pressure. So we're looking for the new volume. And then this is a question mark, and this is 25 degrees Celsius. And we got to add 273, 298. Okay, so let's plug it in. So you got 2.5 times 2.0 divided by 253 equals, and then the standard pressure is 1.0 times V2 over 298. So I'm going to solve this by cross multiplying. So on one side, 253 times 1.0 times V2. Then on the other side, we'll have 2.5 times 2.0 times 298. So I'm going to solve this. So V2, it's technically to 1 sig fig because -20 has 1 sig fig, so it should be 6 liters. I got 5.889, but then I rounded to 6 because I should only have one significant figure. All right, I have some practice for you. And so the first part is just the ideal gas law, which is a good practice. But the second part is where I mix them up and you got to figure out, should I use combined or ideal? And so that's ultimately where you want to end up. There's also a key posted.